Hello, this is Mrs. Correa, and we are going to talk about our last triangle congruence theorem, which is HL, also known as hypotenuse leg. First, we need to recall, what is the hypotenuse? Well, the hypotenuse is when you're looking at a right triangle meaning a triangle with a right angle. The hypotenuse is the side length across from the right angle. It's also always the longest side of the triangle. So this congruence rule says that the hypotenuse of both triangles must be congruent. So I'm going to go ahead and mark those with little congruence lines. The hypotenuse of both triangles must be congruent. And then one of the legs must be congruent. The legs are either sides of the right angle. So this is a leg and this is a leg. We don't need both pairs. We only need one pair. So I'm going to mark one of these pairs. So if it is a right triangle, and you have the hypotenuse is the same, and one of the legs is the same, then you know the triangle is congruent by the HL congruence rule. Number 1, tell if the two triangles are congruent. If they are congruent, write a congruent statement. And we are only worrying about the HL triangle congruence rule, so that's hypotenuse leg. So we're going to look at number 1 together. On number 1, the first thing we need to identify is, are these right triangles? And this little square here means this is 90 degrees on both sides, which means yes, this triangle and this triangle are both right triangles. So good there. The second we need to find out is hypotenuse, which is the H part of your HL. The hypotenuse is the side across from the right angle. So this side and this side. Are they congruent? They sure are. They both have these two little notches saying they're equal to each other. The final thing we need is a leg. That's the L part of this. And a leg is one of the sides on either side of the right angle. And we have this side is congruent to this side. This leg is congruent to this leg. So yes, we have a right triangle, a hypotenuse, and a leg. So yes, this is congruent. And then finally, so that answers part of the question. The other is write a congruent statement. So that means that we have triangle, and we're going to name the triangle. We have triangle DEG. So I'm going to write triangle DEG is congruent to triangle. Now, the angle congruent to D is F, so I have to start with F. F-E-G. So triangle F-E-G. Okay, do the same things on numbers 2 and 3. Make sure you determine, is it a right triangle? Do you have a hypotenuse congruent? And do you have a leg congruent? Number 4. For what values of x and y are the two triangles congruent by HL? Okay, so looking at this one, we have one right triangle and a second right triangle, and they are telling us they're already congruent by HL. So we know the hypotenuses are congruent and the legs are congruent. So let's figure out what matches with what. So we know our hypotenuse is the side across from the right angle, so that's going to be this 20 is congruent to, on the other triangle, y. So we're going to say y equals 20. Okay. Now we also know two legs are congruent, which means that this leg is congruent to this leg. So that means x equals 12. Go ahead and do the exact same thing on number 5. All right, let's look at number 6. Same instructions. We're finding for what values of x and y are the two triangles congruent by HL, meaning the hypotenuse and leg we know are already congruent. So we're going to start by looking at the hypotenuse and legs for this situation. So I'm going to start with the ones that have x's for both of them. So we have a leg that has an x on it, and we have a leg over here that is 3x minus 10. Okay, so I'm going to write an equation. I know that 3x minus 10 equals x. Okay, so that is for my legs. The equation I'm going to write for the hypotenuse is x plus 8 equals 2y minus 3. x plus 8 equals 2y minus 3. Okay, now when we go to solve this, I can't solve this one yet because I have two variables I don't know. But one of the variables I don't know is x, and I know that when I solve this guy, I'm going to find out what x equals. So let's start with this one. So I'm going to start by subtracting x from both sides. I'm going to do that because I like to subtract this x with a smaller value. That way I still have a positive number after I subtract, because 3x minus 1x is 2x. I'm going to bring down my minus 10, and x minus x is 0. From there, I'm going to add 10 to both sides. I'm left with 2x equals 10. I'm going to divide both sides by 2, and I'm left with x equals 5. So now I know what x equals, so that's part of my answer. But then I need to figure out what y equals. So going back to our, jumping over to our other equation here, remember, I couldn't figure this out because I had two unknowns, but now I know what x is. So let's rewrite it. Instead of an x here, I'm going to write a 5. So now it says 5 plus 8 equals 2y minus 3. That is a problem we can solve. 5 plus 8 is 13. So go ahead and simplify that and rewrite your equation. Next, I'm going to add 3 to both sides. So now I have 16 equals 2y. And now I'm going to divide both sides by 2. So y equals 8. All right, that is number 6. Go ahead and use the same process to solve number 7.